Can you hear me now? Yeah. Okay, good. Okay, so again, I'm Gabi, I'm a full-stack blockchain developer. I'm currently working at Bioeconomy on account abstraction, and this has been my focus over the last 1 year. So today, I took the chance to come here and speak actually on how account abstraction and AI can work together to get the Web3 UX to the next level. This is me generated by an AI model. Pretty handsome. I wish I could look like that, but that's why we have AIs, I guess. Yeah, next slide. So I will start with two memes that I found that I couldn't decide which one to use. So there's abstraction everywhere. We have account abstraction. We have chain abstraction. If you have heard about it, probably yes. There's also gas abstraction. So why do we have all of these abstractions? So abstraction is good if you know how to use it. So I will talk about that in the next slides. And this one is like, in Ethereum, we don't know if we want to like allow UX to execute code or we want to use smart contracts to achieve account abstraction. Today, I will be like pushing that button and I will speak like about an ERC which aims to bring like account abstraction. This is the 43.7. Is anyone that doesn't know about like account abstraction or actually who knows about account abstraction? Can you raise a hand? Okay, so for those of you that don't know what account abstraction is, it's basically an ERC, which is 43.7, which I'm going to talk about now, because there are other ERCs as well that bring account abstraction. But this one aims to bring it by not modifying the Ethereum consensus layer, right? So it's an ERC, it's not an EIP. This aims to basically transform like every EOA in a smart contract. And that smart contract acts as a wallet. Now, this smart contract wallet sends some transactions, but we don't call them transactions. We call them user operations. They go through a separate mempool, so they don't go to the like public Ethereum mempool. They go through a user operation mempool. And from here, they are picked up by a bundler. And the bundler is like a miner, but it works with just user operations. So both like the user operation mempool and the bundler are like maintained by different AI providers. So we at Bioeconomy, we have our own user operation mempool and our own bundler. So the bundler picks up these transactions, which are called user operations. It will bundle them together into one Ethereum transaction, and then it sends them to like an entry point contract. Now, the job of the entry point contract is to just validate these user operations. So if we have a DApp and we want to pay for the user operation for the user, there will be a paymaster. And the validation on the paymaster typically says that the paymaster needs to have enough funds to pay for the transaction. And then the user operation goes through another validation, which is the smart wallet validation. This checks things like if the nonce is correct, if there's enough gas for the user operation to be executed, if the signature is correct, and so on. So account abstraction does bring like a few benefits. One is gasless transactions and ERC20. We can pay for the gas in ERC20s. We have flexible signature schemes. We can use ESDSA, which is what we use today in like EOAs, but we can also use passkeys. You can also have multi-sigs and like different kind of signature schemes. Then there is transaction batching. So one user operation from one user can contain many transactions, right? So they are batched together. You can also send like parallel user ops, and this is very interesting because you can basically execute many user operations in the exact same time. This is done by using some different kind of nonce. It's called two-dimensional nonce. It's like a very, very big number. And using that big number, we make sure that the nonce is not replayed in another user operation. And also, yeah, programmable wallets. So we can extend the way wallets work. Now, I want to talk about another ERC. So I know like there are a lot of ERCs, but trust me, this one is like very useful. It basically eliminates the vendor lock-in in account abstraction ecosystem because currently, for example, if we have Bioeconomy, we build a module, some other smart account providers cannot use it, right? So for example, the guys at Kernel or Safe, they cannot use our module because it's made for our smart account implementation. Now, this ERC, which is called modular smart account, it makes all these modules reusable between all these AA providers. So yeah, the benefits are interoperability between different AA providers, also between SDKs and wallets because they don't have to care about the smart account implementation, a faster ecosystem growth because the modules are all compatible between different smart accounts. So if one developer builds a module, all other developers from other smart accounts can use it, as long as it follows the standard. And also there's improved security because you have this other type of module, which is called a module registry. And this checks what modules you are enabled, you can install on your smart account, basically. So we have a few modules already audited and ready to use. So for example, we at our next smart account version, which is called Nexus, we will allow all these modules to be installed on the smart accounts. And this is because we know they are audited and they are safe to use, right? So previously with known 7579 accounts, you can install any module on your smart account, which is not very secure. These modules have been built by the Rhinestone team, so they are a very talented team. We have been working with them over the last few months. Okay, so the smart session module. So are you guys following? It's everything all right? Do we have questions for the end or now? For the end, right? Okay. Yeah, so the smart session module, this is a validation type of module which can be installed on a smart account. Now, I missed saying that on 7579 smart accounts, you can have different types of modules. So you can have validator modules, you can have executor modules, you can have hooks, and you can have fallbacks. This module is a validation module, and what it aims to do is that it brings permission validation of user operations. Now, why, and also of 1271 signatures, yeah. Now, why do we want this? This is especially good for session keys. And these session keys can be used with third parties like AI agents. So this basically gives the power to an AI agent to sign a transaction for you and to execute it while you are offline without having to worry that it can, I don't know, steal your money or something. So you can be chilling at the beach and letting the AI agent to do the work for you and not having to worry about, I don't know, that it can steal your money because you have specified some policies, limitations, like spending limits, rate limits, contract interactions, like it can only interact with Uniswap smart contracts or so on. Now, we also have this done as a Bicanomy product, which is like an off-chain trustless session key storage. It comes from decentralized autonomous network, and in simple terms, it's an MPC network where you can store things like private keys, or in our case, a session. Okay, so this is the workflow, or basically the simple workflow of how smart session validation happens. So you have the 7579 smart account, which checks if the user operation is valid to this validator. This checks the policies like limited max amount, limited to certain actions, rate limit, so on. And then it goes to checking the signature. So there's a signer, which is included in a session object, which is shared with, for example, an AI agent. Now, this signer has the power to sign and send transactions, right? So we delegate it to an AI agent. It can sign with passkeys, multi-sig, or different signature schemes. And it's also async, meaning that we don't have to worry about it, right? So we are offline and the AI agent is signing for us. But in the same way, it's very permissioned because we gave it the policies and permissions. Now, how to leverage AI with this module and this smart account version? So we can use natural language processing models to get the user intent and then transform that user intent into actual transactions. And you can use something like machine learning classifier to analyze the user behavior, analyze market trends, analyze market conditions, maybe past user transactions, and then you can come up with the best permission object for the user so that he doesn't have to know what permissions to really give to the AI agent, but we recommend something for him. Of course, if he wants to change it, he can change it, right? Yeah, so this is done because creating permissions and policies is like very difficult for both a developer and the user. It's difficult for the developer because like it also has to know what will be like how to implement this in code, right? And for the user, it's difficult because he has to know what permissions to give the AI agent so that he doesn't get rugged or something after. Now I know I talked a lot, so probably we didn't get it fully, but this is like a representation of how it happens. So there is a user, he comes to the AI agent, he says something like, I want to trade for the next few hours. So this is an intent. Now the AI agent uses something like a natural language processing model. And this is something that the team at Brian are doing, so shout out, guys. So it constructs the permission object behind the scenes, something like, for example, for this user. It will create a permission that for the next 4 hours, the session will be available. You will be able to spend just $500. You will be able to execute just 10 user operations. Maybe it won't go, it will not allow to spend for a user operation more than $50 of gas, right? Because we don't want to pay a lot of gas for transactions. It will limit the interactions with specified contracts. So it can say something like you can only interact with these Uniswap smart contracts. And you cannot transfer assets to other address than this one. So it creates this permission object. It displays it to the user on an interface, and the user signs, right? So if the user approves, he signs this object, and this is stored now on the AI agent side. But we need like a safe place to store this session, because if someone else gets access to it, it can sign the transactions and send it, right? But even in that case, we know we gave it some permissions and policies, so we are not afraid that it can do like anything on our smart account. So the best place to store this is like an MPC network. So now this AI agent has these permissions for future use. So whenever he thinks that it's like the best case to execute a transaction, it can build a user operation and sign it with the session key. For example, let's say the Bitcoin price dropped over 60,000, right? So it spots a really good opportunity to buy Bitcoin. So it builds a user operation, it signs it with the session key, and then the user operation needs to be validated by the Smart Session module, which is installed on a smart account. Now the validation here will check every policy and user operation that the user has assigned to his smart account. It will check if it's transferring more money than he has allowed to, if the gas spending is too high, if it interacts with any smart contract that he hasn't allowed the smart account to interact with. And after it validates the user operation, it's executed, right? So again, this happens regardless of a user online status. So you can do anything else, and the AI agent will do the work for you, and you don't have to worry that it can do anything because you gave it specific policies and permissions. Now, some key takeaways. Modular smart accounts are here to eliminate the vendor lock-in in account abstraction. Smart sessions are here to bring us permissioned use. Yeah?
I have a question regarding the slide before. Why does the signed permission object has to be stored securely? Because the user can specify like exactly the
Yeah, that's a good question. So this signed permission object, basically, so when I'm saying this, is like this is the whole session object, right? The session object typically has a signer inside of it, which means it has a private key also. And that private key is used to sign for the transactions for the user while he is offline. So if the session gets like, I don't know, if someone else gets access to this session, it can sign the transactions for our smart account in the same way the AI agent could. But again, it's still permission, right? So it cannot do more than we have allowed it to do. But we don't want to share this with anyone. We just want the AI agent to do it. So the short answer, it contains a private key inside it. So yeah, it needs to be stored somewhere safe.
Why does it contain the private key?
Because it needs a private key to sign for transactions, right? So you need.
It can, but I thought it's already signed and then stored.
No, what we sign here at this step is the authorization for the AI agent to use our session. So we signed it. It creates that session object with the signer inside of it, and then the AI agent will use that. So we need a private key stored somewhere so that we can sign offline, right? So yeah, as I said, model smart accounts to eliminate vendor lock-in, smart sessions to bring permissioned user ops. The done is here to store the sessions in a decentralized storage. Natural language processing to get the user intent and transform it into actual transactions. And machine learning classifiers can help us to analyze user data, user actions, market conditions, and come with recommendations for either sessions or things like portfolio management. Yeah, so that's pretty much it. If you have any other questions.